Um, Hello and good morning, good afternoon, good evening, wherever you are, looking at this video from. So today I'd like to take this opportunity to show you how we can build a model in Proto Simulation and what are the different, ways by which you can look at your results. So if you have Proto installed on your computer, you will most likely see an icon, something like this. We have the latest version for Proto, which is version 2020. And I have at my toolbar here, I have the icon for Proto Simulation, which is here. So, and I'm going to start Proto. So if you would have worked with Proto in the past, I would like to just give you a little information. Then in the past, it used to be called as just Proto. Recently, Aveva has changed the name a little bit, and now it is called as Aveva Proto Simulation, following by the year in which it is released. So the latest version for Proto is Proto Simulation version 2020. And as you can see here, this is the graphical user interface of Proto, how it looks like when you open up. Obviously, if you have a license, you will be able to run the simulation, build a simulation. So let's go ahead and build a simulation. And the very first thing I will do is I'll click on this new button here. There are various ways you can build, access the various functionalities of Proto. One of them is this using this, ribbon view. The other one would be, you can go to the specific tab and then look for the certain, feature that you're looking for. But the main tab that you will usually be working with in Proto would be this Express tab. So I'm going to click on New and create a new simulation. As you would have been observing so far, that has a very much of a look and feel of any Microsoft application. It's got a menu bar, it has got a toolbar, then the area where you would be basically working with your application. So when you open Proto, you see sort of like three windows, which is the message window here on the left, and then you see the flow sheeting area, and then you have the PFD palette on the right. This PFD palette basically consists of all the unit operations which are in Proto, and it has been divided into various tabs. Now, for example, any unit operation across which you would see a pressure change is under the pressure change tab. Like, for example, a compressor or an expander, a pump or a valve, all these unit operations across which we see a pressure change. In the same way, we have, let's say, the heat exchanger tab. Now, this heat exchanger tab is basically, all the heat exchangers which are there in SimSen, in Aveva in Aveva Proto Simulation is under the heat exchangers tab. Now let us look at what we have here on the left side. This is the messages window. And in this messages window, whenever you run the simulation, the number of iterations that it has taken, if there are any errors or if there are any, warnings and these kind of messages during the simulation, you will be able to see them appearing here. And this obviously is a flow sheeting area where you can build a flow sheet. So first and foremost, Proto simulation is a steady state simulation, which means that which means that the controllers, the transmitters, or any sort of such instrumentation are irrelevant for the software, because it doesn't really do any level control. It would not do any pressure control, and hence, when you are looking at a PFD and you're trying to build that in Proto, you do not need to input the level controllers, pressure controllers, or anything of that sort. In Proto Simulation, there are 7 steps to build a simulation. The first step, and I'll go through the 7 steps in one by one. And all these 7 steps, you will be able to access them from the Express tab. So the first thing I will do is I see a little background noise coming, so I'm trying to pause that. Anyways, so as I was saying, there are 7 steps to build a simulation in Proto. The first step is to select the units of measure. So let's say you have on your the process that you're trying to build is using SI units. So the first and foremost thing that you would do is select the same units of measure for the simulation. So let's go to the units of measure tab, a tab which appears on the toolbar here. Let's take the units of measure, and then let's say we want to work with the SI units. You'll have to click on the initialize from the UOM library. I'll click on the UOM library, and here you can say initialize from. So you have a few number of unit operations. So I have the English units of measure, metrics, and SI. So let's take the SI because that's what we want to work with, and then let's say okay. If you do not want to work with Kelvin, you would like to work with Celsius, then you can specifically only change that particular parameter. Let's make it Celsius. All right, so we've seen the first step, which was selecting the right units of measure. The second step is to select the components. Now, whatever raw material, intermediate products, finished products, whichever component that you would see on your process, that you should be selecting from the component selection box. So here you on top, you see there's a benzene ring. So when you click on that, it opens up the component selection box where you can select the name of the component and add them. So for our demonstration, I'm going to take some hydrocarbons. So let's say we have methane, we've got ethane, we've got propane. So spelling mistake. So we have propane. So if the name of the component is less than 8 characters, you will be able to type them here and you will be able to select them. If it is longer than 8, then you will have to go to select from list. So I'm going to click on select from list. Let's say we have a hydrocarbon which has got a name of more than 8 characters. And then when you come onto the component selection list, here you can see the different types of data banks we have available in Proto. The first, the basic data bank that we suggest everybody to work with is called as a SimSci data bank. There are 2 types of data banks we have, SimSci and Process. Process is an old data bank which we have really not, built, or we have not really been, worked or improved on. SimSci data bank is the data bank which one should work with. So let's go and select any component which is probably more than 8 characters. Okay, I'll just scroll down. So you can see there are like around 1900 to 2000 different types of components. Okay, I'll just take, let's say, benzene aldehyde, and you can click on add components, and this particular component is also selected in your list of components. And then I will say okay here. So now we have 4 components. 3 of them have got less than 8 characters, so we could select it from here. Benzene aldehyde, we had to go and select it from the select from list. So that is our second step. And as we progress, you would observe that these buttons now, the unit of measure button, the component selection button, they have got a blue border around it. So if you carefully observe the first button, which is the input description, right now it has got a green border. A green border button, or any place where you see any data entry point which is in green color, it is just an indication that it is a default value. And if you don't change that, it doesn't matter. You can leave it as it is. So now input description, for example, if I click on that, these are empty. It's not mandatory for you to input the project identifier or the problem identifier. So that is why it is just a default and it's still appearing as green. Wherever you see a red border, like for example, right now in thermodynamics, If you see a red border, that means you require some information here, without which it doesn't go forward. And hence, some of them are green, some of them are blue, and some of them are red. Blue is an indication that a user has provided some information here. So since we selected the units of measure, since we selected the components, that is the reason they have got a blue border. So now let us go and do the third step, which is selecting the thermodynamics. And since we are working with the light hydrocarbons, let's go and select the SRK, Peng-Robinson, whichever equation or state method that you want to work with. These will be good enough for light hydrocarbons. So let's select swap Redlich Kwong and OK. Then Proto gives you a possibility that if you want, let's say, the liquid density to be calculated using a specific thermodynamic method, not the API method, you can come down here by clicking on modify, and then you select, for example, for liquid density from the drop down, let's say we take Costal-D method. And specifically for that, we have changed. And as you can observe, the moment I change that, you will see that this modify button will become blue in color. So this is an indication that user has selected a thermodynamic method which is different than what Proto has selected for the SRK method. Okay. And if I go back to API, that is no more blue. So let's just keep it at the default and move on. So we have done the 3 steps: units of measure, component selection, and thermodynamics. Now the 4th step is to build the flow sheet. Now, obviously, if you are building a very large flow sheet, let's say you're building an ethylene plant, I'm not suggesting that you go ahead and build the entire flow sheet at one go. The best practice in Proto Simulation would be, or any simulation for that matter, would be that you build sections of that plant or the process in steps, converge, and then move on further. So we'll take a very simple example here of a separator with a compressor and a pump, and we'll see how whether it converges before moving forward. So our 4th step now is to build the flow sheet. Building the flow sheet in Proto consists of, first of all, selecting the units of measure, selecting the unit operations that you want. So let's say we have a unit operation which is a separator, which is nothing but a flash drum. So let's take a flash. Then we have, let's say, a compressor, put it here. We have a pump for the bottom product stream. Then let's say there is an after cooler. So let's go to the heat exchanger and select a simple heat exchanger, place it on the canvas. And as you can observe here, I'm just clicking once on the unit operation, and the second time I'm clicking onto the flow sheet, and that is how we select. And after that, let's say we have a valve. So let's go back to the pressure changer and select a valve, and let's place it here. And let's keep this as a simple model. And now let us connect them all with streams. So first stream you would require is the feed stream. So I'm going to click on the feed stream and connect it to the flash drum. As soon as you click on the stream, all the borders for the unit operations, they have this red color, as you can see here. The compressor, heat exchangers, pump, valve, all have got this red borders where or ports where you can connect the stream. For a flash drum, there is no as such port, but there is a long port, because you can have it's just an indication that this all you can connect the stream anywhere on this particular side of the flash drum. So I'm just going to connect the feed stream. Then you have the overhead vapor stream, discharge of the compressor going to this after cooler, and the discharge from the after cooler. Let's do that for the flash drum now. From the flash drum bottoms going to the pump, discharge of the pump going to this valve, and discharge from the valve. And I'm going to right click now, and you will see this at the moment. My cursor has got it's in a mode which is stream selection mode. And if I right click, that stream selection mode will disappear. It will become like a normal selection. Right click, and now it is gone. Okay. So this is our 4th step. I can click on zoom full. So it becomes, it takes up the complete space of the flow sheet. So that's our fourth step. The fifth step is to provide the stream information. In Proto Simulation, you cannot, or basically you're not required to provide any information for these internal streams. Internal streams are streams which are connecting two unit operations. So S2 is an internal stream, S3 is an internal stream, S4 is a product stream. So all these, where there are stream which is connecting two unit operations, this is an internal stream. We don't need to provide any information for that. As far as the product stream are concerned, you don't have to provide any information. These are getting calculated. These will get calculated by Proto once the simulation is run. So the only thing that you require to give is the stream information for the feed. So let's double click on that stream and provide the information required here. And it is very easy for you to navigate, because wherever you see this red border, you can click on that and provide the information. You will not miss anything. So for example, even if you just look at the flow sheet, you know that which are the streams or unit operations that I need to provide information for. So it's very easy. I double click on this. I know that here it is missing. I'll click on that. Then I see this border that it is missing. I need to provide information here. So firstly, let's give it a total flow rate. So let's say it is about 100 kg moles, or 100 kg moles per hour. And then let's say we have about 0.4 of methane. We have got, let's say 0.3 of ethane. And let's say we've got 0.3 of propane as well. Let's say 0.2 and 0.1. Let's do that. Right. So if it sums up to 1, Proto understands that you have given a the composition in terms of fraction. If it sums up to 100, it understands that you've given the composition in terms of percentage. Now, if you do not want to give the composition in mole, it has to be in mass. Just click on the box here, the data entry box here. The units of measure, this becomes live. So you click on that, and you can convert that into mass. And you say, okay, this is mass percentage or mass composition and not mole. Same way here, if you think that you don't want to give it in kg moles per hour, you want to maybe give it in vapor flow rate or liquid flow rate or something like that, you can select that from this units of measure. It only comes active, I'll show you. Let's go back to the stream. This units of measure button is only active when you click on that particular box, the data entry box. When I click on that, this becomes active, and then only you can change the units of measure. So this is local change. It is only happening for this particular unit operation or this particular stream, not for the entire flow sheet. After giving the composition and the flow rate, you need to give the temperature and pressure, or thermal condition, basically, first specification and second specification. So first specification could be temperature or pressure. So let's say you select pressure of about 500 kPa, for example. Then you have the second specification. You can choose any one of these. So you say temperature, bubble point, and so on and so forth. So let's make it simple. Keep it as temperature about 25 degrees Celsius. And we say OK. So this is our fourth step. So 1, 2, 3, 4. In fact, the fifth step, to provide the stream data. Now the sixth step is to provide the unit operation data. As you can see, the flash is requiring some information, compressor, heat exchanger, and the valve. Pump doesn't require anything. The reason being, if you double click on the pump, by default, it is taking a pressure rise of 0, which means that whatever pressure comes in for the stream is what is getting delivered. So it's not really a pump. It's the pump is not doing any work as such here. So let's give the information for the flash first of all. And let's say there's no pressure drop, and the duty is also 0. So let's make it as an adiabatic flash. Then let's go to the compressor. And let's say we have the outlet. We don't have let's say the outlet pressure. Let's say only we have a pressure ratio. So we say, let's say it goes up by 4. And the efficiency, adiabatic efficiency is, let's say 75. And so, okay. And finally, we go to the heat exchanger or the aftercooler. And we say that what we require here in terms of the product temperature. So let's say we want the product temperature to come down to 25 degrees Celsius. So it will calculate the duty for us. And then we have the valve also remaining. Let's click on the valve and give it an outlet pressure, or let's say, let's give it a pressure drop of say about 100 kPa. And let's give some pressure rise in the pump, or let's say pressure ratio, maybe let's make it as 3. And if you want, we can give the efficiency, mechanical and pump efficiency. I'm going to just skip it for the moment. So these are the 6 steps, and as you can see, now I don't have anything left on the flow sheet to specify. And that's when you have the run button available for you to run. If, for example, I remove this, I did not show this earlier. If I remove this, you don't have this run button available. And even if you click on the run button right now, you see it will tell you that, oh, this valve is incomplete. Can you please give the information for the valve? So let's go back to the valve. We want 100 kPa of pressure drop, and we say okay. So this is the 6th and final step before running the simulation. And then the 7th step basically is to run the simulation and view the results. So I'll run the simulation. And Proto very neatly highlights to you if the simulation has solved or it has not solved. If it turns blue in color, this is an indication that the simulation has solved. If it turns red in color, it is an indication that it has failed to converge. Sometimes you will see that the unit is appearing green in color for some time, which is just an indication that it is still calculating for that particular unit. And sometimes even after it has converged, it remains in a yellow color. So that is an indication that there are some warnings you should have a look at. So that's all for in terms of running the simulation. Now, if you want to look at the results, there are various ways of looking at your results. One of the very easy ways of looking at your results is just take your cursor onto the stream, and it throws a tooltip. This particular small window that comes up is a tooltip. It tells you basically temperature, pressure, and flow. And if you take it to a unit operation, it tells you the parameters associated with that particular flash drum. And as you remember, this was an adiabatic flash, hence the duty is 0. Temperature, pressure doesn't change. If you go to the compressor, it is telling you that, okay, this is my shaft work, this is the actual head, and so on and so forth. And if you go to the stream, it tells you again what is the pressure and all that. So this is one of the easiest ways of looking at your results. The other way of looking at your results would be to build something called as stream property tables. So we'll go to the output tab. We'll go to the output tab, and then we will go to the stream property table. And let's select the stream property table. You will see a box gets linked to your cursor, and then we can come and place it somewhere onto the flow sheet, and you have a box like that appearing. When you double click on that box, it tells you what are the different streams you have available. So we can say, please select all the streams for me, and I would like to see the results, which gives me the material balance for my process. And let's say we want to see some grid lines so that it looks clear. And when you just say okay. So when you do that, you see that a stream property table, which looks, or results views looks something like this, will appear. And this is a live link. If I make a change in S1, for example, let's make it 525 kPa, and just observe here the pressure. When I say okay, right now it is not changing because this is a results table, not an input table. It's only showing the results. So that means when you run, then it will get updated. As you can see here, now it has gotten updated, and accordingly the other pressures they have gotten updated as well. Well, there are many ways of looking at your results. This is just one of them. I can show you one more interesting way of looking at your results, which is Excel based. So let's for that go to output, and you can see on the top here, generate Excel output. Right now it is grayed out, And before for that to appear for us, we need to save this. Let's go to save as and whatever default directory. So let's make it as demonstration1 and save it. So now we have this saved. Now, and once you save it, you see that you have the general Excel output. Sorry, generate Excel output is live button. And on this tab here on top, you see there are two different types of reports appearing: summary report and detailed report. This cost estimation report is something else. We're not talking about it right now here. So summary report and a detailed report, either of these two types of reports you can generate. So let's say you want to see the summary report, and then you click on generate the Excel output. It takes a little time. It all depends on how fast the computer is, and to start up Excel, and how big the flow sheet is. So it's open now, and once the Excel report comes up, it will look something like this. And the first button will be the input file. This is the file. This is like, it's like a small program that you have written. This in Proto is called as the input file, or the .inp file. This is like a small, code that you have written. Then it gives you the solution history. What were the number of steps, which were the number of unit operations, and if there were any errors or whatever, and then you go back to index, and this is your tab, main tab. This is where you get the results for all your unit operations. So alphabetically, it will start from the units. So the compressor is coming first, then you have the flash drum. So if we had 10 flash drums, they will all appear in columns next to each other. If we had like 5 compressors, they would have appeared like in E, F, G, and H, so and so on and so forth. Then we have the heat exchangers results. Then we have the results for the pump, for the vessel, or the flash drum, for example. For the valve, not the vessel, for the valve. And then finally we have for the streams. So these are the different types of streams we had, 7 streams. For all of them, you will see the results. So it is quite extensive. This report, you'll see all the information that basically you require will appear here for the streams and for the unit operations. So that's how you would basically build a simple simulation in Proto and view the results onto the flow sheet and on Excel.